Welcome in the second section of our course. In this section we'll be looking at the data processing using MapReduce. So we'll be delving into MapReduce paradigm and we will be trying to understand how to write big data jobs according to it. So we'll be looking at the RDD. This is a resilient distributed dataset that is available in Apache Spark API. We will see how to partition our data. Also, we'll be learning about Spark APIs. And at the end, we will write a Spark job that is doing some computation that is high and extensive. And this is first video of our second section. In this video, we'll be looking at the MapReduce job architecture. So we'll see what a MapReduce job is and how to calculate word count in a distributed way. So we will be given a problem of calculating word counts of huge file and we need to distribute that processing somehow. We will be trying to understand how MapReduce is approaching that problem. So let's look at the overview without extensive details. So firstly, let's say that we have input. We have three files. First file has a Jimmy, Jen and Jerry, so 3 strings, and number of occurrences of that string in this file. Then in MapReduce job, we have a mappers, so this is a first phase of our processing, and then we have reducers. Reducers are doing joining, we can say that, of our results and are producing final result. So at the right hand side of this diagram, we can see that Jenny occurred 4 times, Jerry 2 times, Jimmy 2 times, and Johnny only once in our input. And in this section, we will be trying to focus on what is happening between input and result, and we will be coding that program in this section. So let's look at the MapReduce word count problem statement. So we have a map phase, we have input where is file name, and inside of a file there is a text. We need to parse file and emit pairs of word and count. So every occurrence of word will be transferred to the tuple of word and count. And in the first phase, map phase, it will be equal to 1. Then reduce phase is taking all tuples and summing all tuples with the same word as a first element in a tuple. So hello, for example, will be summed with 3, 5, 2, 7 and the result will be 17. So this is a problem statement and how MapReduce is approaching it. But let's look at that problem in more detail. So in this example we have input and this is one flat file. And inside of that file we have words separated by the white space. So in the input we have deer, beer, river, car, river, and so on. The first phase in this job will be to split that input into partitions. So first part of that file is split to one partition, second part into second, and so on and so on. Due to that fact, we are able to execute all statements in parallel. Then mapping phase is taking every word from the first partition and mapping it to tuple when first element is a word and second is count. We can see that deer is mapped to deer 1, beer 1, river 1, and so on and so on. And this is happening for every partition. Next, the shuffling appeared. So every server is taking only elements that has the same key, same first value of tuple. So beer 1 from the first partition and beer 1 from the third one is transferred to the first worker. Because of that, the first worker has all values that are associated with the beer string and that worker is able to perform reducing on that word. Reducing is just appending and summing every element that is inside of that list. So after reduce there is beer 2. And final result, so every worker can save result to the final file, so beer 2, car 3, deer 2, river 2, and so on and so on.